So, good morning, everyone, and welcome to this lecture. We are into the last lecture, I think, for capacitance, and we were dealing with the dielectrics, and we had seen how we can find out the capacitance when a capacitor is filled with different dielectrics. Yes or no? No, yes. Do we remember this? I think I put the wrong thing. We are lecture number 11 or 12. This is, I think. This is lecture number 12. No, this is lecture number 11. And we were dealing with dielectrics, and we had
Yes, sir.
you're able to hear me, no?
Yes, sir.
Okay, I was getting the message that uh, audio is not you're getting there. Okay, so we were dealing with the dielectric, and in this case, the dielectric was not completely filling up the space. We had found out that we can find out the new capacitance from this formula if there is only one dielectric. Do we remember this formula? Yes or no? No, yes. Everyone remembers this formula
Yes, sir.
that we had discussed in the previous class of how to find capacitance when it is partly filled. We had also seen that if there are not one but not two but a large number of dielectrics filled, we can use the other formula, the general formula for finding out the capacitance. Yes or no? Do you remember this formula, the general formula as well? Yes or no? Do we remember this formula?
Yes, sir. Yes, sir.
Okay, okay. Now what we will try to do is try to solve some questions based on this. And let us start with this question. And remember, this is a question from previous year IIT. But I hope that you will be able to solve this. Can I give you the question? So here comes the question for you. So in this question, what is there? A slab of copper of thickness B is inserted between the plates of a capacitor. The separation between the plates is D. If the thickness B is D by 2, what is the ratio of capacitance before and after inserting the slab? I think we have not done the question. We have not done the case of conductors, and here in this case the conductor is inserted. So let me first give you a question where the conductor is not there and it is a case of only dielectrics. So let me give you this case first, then we will see that question and do that case. Okay, so find out the capacitance in this case. So this is the question that I am going to give you. Find out the capacitance between A and B if dielectric slabs K1 and K2, thickness D1 and D2 are inserted between the plates. So this is completely filling up this space. Do we know how to do this question? Yes or no? Do we know how to do this question? Yes or no? I'll give you 2 minutes to solve it. So how are we supposed to do this question? This is the case where the two dielectrics are completely filling up the space, and we had seen the formula when they are completely filling up the space. Do we remember this formula? Do we remember this formula when they are completely filling up the space? Do we remember this formula? Yes or no?
Yes,
Not
sir.
able to see you, not able to hear you. Do we remember this formula? That's it, my dear friends. That is the formula we need to put here. That is the formula that we need to put here. So what will be the capacitance in this case? Can anyone tell me? The capacitance C dash in this case will be epsilon naught into A divided by D1 by K1 plus D2 by K2. Do we understand this? Do we understand this?
Yes, sir.
Everyone understands this? Can I have, everyone knows this? Both the classes?
Yes, sir.
Okay. Have you noted this question down? Then I'll give you one more for you to do and tell me the answer. So this is the next question. Have you noted down this question? Yes or
Yes,
no?
sir.
Okay. Now this is the next question that is coming here instead of two. As you can see here in this question, we have three dielectrics put in this fashion. You have to tell me which is the correct option. Among the options given, three dielectrics are filled. May I have the answer for this one? May I have the answer for this one? What will be the capacitance in this case? Option A, option B, option C, option D. Which one is the correct option? Anyone?
Option A, sir.
Option A is the correct option. Everyone understands this?
Yes, sir.
I'm not getting a response from the other students. Do we understand this? Option A.
Yes, sir.
Okay. So, if these type of question come, I hope you will be able to do them. I'll give you a minute to note it down. Meanwhile, I will make one more question for you to solve. Everyone has noted down?
Done, sir.
Okay, sir.
Sir,
Then,
1 minute, sir.
okay, note it down. Note it down.
Yes, sir.
Then comes this question, sir. You have a capacitor filled in this fashion. The dielectric constant of the blue part, as you can see, is K. The dielectric constant of the green part, as you can see, is 2K. The distance between the plates is D, and it is half filled with K and half filled with 2K. I'll give you 2 minutes to give me the answer for this one. So let me do it for you. How will I find the capacitance of this capacitor?
Sir,
Yes, beta.
epsilon naught by 3D by 4K.
Okay, so how will I get the answer for this one? This will be epsilon naught A divided by, it is filled with two dielectrics. So d1 by k1, the first distance is d by 2. So d by 2 divided by the capacitance k, dielectric constant k. This is for the blue one. Do we understand this?
Yes, sir.
This is for the blue one. Then I have one more dielectric here. I have one more dielectric here, d by 2, distance d by 2, and dielectric constant is 2k. So for that it becomes d by 2 divided by 2k. So it becomes d by 4k. Yes or no?
Yes, sir.
We just need to now take the LCM and get the answer. So what will be the answer you will get? D by 2k plus d by 4k will become 3 by 4. And the final answer that you will get will be 4 epsilon naught A into k will come in the numerator divided by 3 times of d. This is the final answer that you are going to get. Do we understand this, everyone? Do we
Yes,
understand
sir.
this? How many of you got the answer for this one?
Got it, sir.
Has everyone noted this down? I will give you one more question.
Completed, sir.
I will give you
One
one more
minute,
question.
sir.
Yes, I am giving you time. I'm giving you time. So solve it.
Done, sir.
Solve it, and then I will give you one more question. Everyone has written down the solution. Let me know. Then there is one more question waiting for you. One more question waiting for you. Shall I give you the next question?
Yes, sir.
So here comes the next question. You have three dielectrics now. The dielectric constant of the blue one is K, the green one is 2K, and the red one is 3K. All the distances that are there is d by 3, d by 3, and d by 3. So I'll just write 1 as d by 3. The area of the plate is given as A. Three plates you have now, three dielectrics you have now. The blue one, the green one, and the red or the pink one. You have to tell me the capacitance of the system. I will give you 2 minutes to do that. Okay, I think that is the correct answer. How are we supposed to do this? Let me give you the formula. Let me write the formula, and I will leave the calculation part for you to do. How do I do this? So I write the formula C dash. C dash will be equal to epsilon naught A divided by, for the blue one. For the blue one, we have distance as d by 3, and the dielectric constant is k. So this becomes the blue one. Everyone got this? Yes or no?
Yes, sir.
Then for the green one, the distance is d by 3, and the capacitance is, the dielectric constant is 2k. So this becomes d by 6k. Do we understand this, everyone?
Yes, sir.
But we have one more here, so don't worry, we will add this one as well. Distance is d by 3, dielectric constant is 3k, 3 into 3 is 9. So divided by 9k, and this becomes this one. Do we understand this?
Yes, sir.
Now I think after that you can take the LCM. I think LCM will come as 18, and you will have the final answer as 18 epsilon naught A into K divided by 6 plus 3 plus 2, 11K. That is the correct answer. 18 epsilon naught AK by 11. Everyone understands this? Yes or no? No, yes.
Sir, it's 11D, sir.
Yeah, 11D, sorry. 11D. Do we understand this, everyone?
Yes, sir.
So this is the concept of dielectric inserted in the plates in this fashion. Everyone has understood this?
Yes, sir.
Now, up till now, the dielectric was inserted. Now, what happens if section B, metallic plate is inserted? Metallic slab, copper, aluminum, anything which is metallic. If that slab is inserted, then what will happen? Then what will happen? That was the question that I gave you. I did not read the question properly. And that was the question that I gave you to solve from that IIT wala question. What happens when a metallic plate is inserted? The second case is when a metallic plate is inserted. Now remember, when a dielectric is inserted, I have given you the formula. When a metallic plate is inserted, can anyone tell me what is the dielectric constant of a metallic plate? I had told you that in the previous class. I told you that in the previous class. What is the dielectric constant of a metallic plate or a metal? Anyone can tell me? Abhiram says between 1 to infinity. What is the what is the what is the what is the dielectric constant of a metallic plate? No one remembers it. Anyways, the metallic plate has a dielectric constant which is infinite. I have told you this thing 4 times and you still don't remember it. Well, my fault. Maybe I'm not able to say that in a language that is understandable. So I accept my apologies. Please accept my apologies. And please remember that the dielectric constant of a metallic plate K is infinity for a metallic plate. For a metal, for a dielectric, it is between 1 to infinity. Please remember that. Please remember that. And please remember that. Now, if I have a metallic plate which is inserted between the capacitor, between the plates of a capacitor, the thickness of this metallic plate is D. I can use the same formula of dielectric, but here K is infinite. So in short, if I say the original formula is epsilon naught A by D, that is the original capacitance of this capacitor. When this dielectric, when this metallic plate is inserted, my dear friends, the capacitance becomes C dash, the new capacitance becomes epsilon naught A upon D minus T, that factor of T by K, because K is infinite, very large, that factor of T by K disappears and this becomes my new capacitance. C dash becomes epsilon naught A upon D minus T. I can find the ratio of C dash by C. If I find the ratio of C dash by C, it will be coming as D upon D minus T. So this is what you got to remember. I will give you 2 minutes to note down both of these formulas. Both of these formulae, please note them down. When a metallic plate is inserted, I'll give you 2 minutes. Note down the formula. Tell me once you are done. Well then, let us move ahead and see one more case here. Now here the metallic plate is not completely filling up the entire space. So I can call this case as case number 1, where it is partly filling. You can call this case as the metallic plate is partially filling the space. This case is metallic plate partially filling the space. Now there can be one more case. What would be that one more case? Anyone? What would be that one more case? What would be that one more case? When the metallic plate completely fills. When the metallic plate completely fills up the space, so you can write the next heading as metallic plate completely filling up the space. So whatever space is available is filled by the metallic plate completely like this. I hope you can see this. The metallic plate is completely filling up the entire space. Can anyone tell me what will be the capacitance now when it is completely filling up whatever space is available? It is completely filling it up. It is completely filling it up. What will be the capacitance in this case? Remember, the capacitance in this case will become infinite and it will not be defined. So remember, in this case, the capacitance becomes not defined. It becomes infinite. Now, you can see this case like this, or this case can be written like this also. Instead of completely filling up, instead of completely filling up, in place of completely filling up, you can join the plates of the capacitor by a wire. This is the positive or first plate and this is the second plate. And if I join this by a wire, don't have to completely fill it up. If I join these two plates by a wire, if two plates of the capacitor are joined by a wire, in that case also the capacitance becomes infinite and it is not defined. So that is one thing that you must remember. Important point, if plates of a capacitor are joined by a wire also, or completely metal is filled, the capacitance becomes infinite. Do we understand this? So both of these cases, if I call this as case number 1 and if I call this as case number 2, both of these cases are same. Here, the capacitance in both the cases becomes infinite. Do we understand this?
Yes, sir.
I'll give you 1 minute to give me to note this down. Then let's move ahead and solve this question. Here, a copper slab. Copper is a conductor. Metal conductor is placed in between the plates of a capacitor. You have to find the ratio of, you have to find the ratio of, remember the ratio of capacity after and before inserting the slab. I'll give you 2 minutes to solve this. Well, that is the correct answer. Option B is the correct option. Well done. How did we do this? Metallic plate or metal or conductor is insulated, is inserted. I know the formula C dash by C will be equal to D upon D minus T. You just need to put the values here. Just need to put the values here. So D is D divided by D minus T. So thickness is D by 2 given here. So the answer will be 2. So the ratio becomes 2:1. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone understands this, sir?
Yes, sir.
I'm only getting one voice. I need more voices. Do we understand this, sir?
Yes, sir.
Okay.
Yes, sir.
Then comes this question, sir. Give me the answer quickly, sir. Aluminium. Aluminium is again a conductor. Is inserted between the plates of a capacitor. What will happen? What will happen, my dear friends? What will happen? What will happen to the capacitance? Capacitance of this capacitor. What will happen, my dear friends? If aluminum strip, they have only inserted an aluminum strip, thin strip. What will happen? What will happen? When aluminum strip is inserted, aluminum is a conductor. What will happen? Capacitance increases, decreases, remains same. It may increase, decrease. Yes, what is the answer? And the answer is
B, sir. Option B.
option A. The capacitance will increase. Remember, the formula is C dash by C, D upon D minus T. So the answer has to be, it will always increase, because capacitance becomes epsilon naught A upon D minus T. Distance decreases actually, and therefore the capacitance increases. Do we understand this? Yes or no? We understand this? Yes or no?
Yes, sir.
Everyone understands this? Yes or no?
Understood, sir.
Okay, that takes us to the next case. Dielectric are inserted by division of area. What do I mean by division of area? What do I mean by division of area? Anyone, any idea what do you mean by division of area? By division of area, what I mean is the dielectrics would be inserted in this way. One dielectric here, whose dielectric constant, let me just take this off, whose dielectric constant is K1, having an area of A1, and another dielectric whose dielectric constant is K2, area A2, and the area of the plates is given like this. Do we understand? Total area of the plates is A. It has been divided into A1 by 2 and A1 and A2. It's division of area. Do we understand this, everyone? Up till now, can you see the difference between the two configuration? Up till now, plates were like the dielectrics were completely filling up the area, not the complete distance. Here they are filling the complete distance, but not the complete area. Do we understand this?
Yes, sir.
The original capacitance is always equal to epsilon naught A by D. The new capacitance C dash becomes, and this formula is quite simple, epsilon naught by D into K1 A1 plus K2 A2. Do we understand this? Yes or no? No, yes. So this is
Yes,
the
sir.
formula that you must remember. A very simple formula. C dash is epsilon naught A by D, K1 A1 plus K2 A2. Now, if someone asks you what is the ratio C1 C dash by C1, you can simply say K1 A1 plus K2 A2 divided by total area A. Is it clear to everyone what we have done here? Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes to note it down. Now we have this case where if I have equal areas, so this is, let us say, dielectric constant K1, this is, let us say, dielectric constant K2, and let us say both the areas are A by 2 and A by 2. Both the areas are equal. In that case, the original capacitance is epsilon naught A by D. I hope you understand this. The new capacitance becomes epsilon naught A by 2D because both the areas are same. K1 plus K2. Do we understand this? Or you can take this 2 inside. You can take this 2 inside and write it like this. Do we understand what I've written here?
Yes, sir.
I'll give you 2 minutes to note this down. I have a question for you. I have a capacitor which is filled like this. The blue one has a dielectric constant K and area is A by 2. The pink one has dielectric constant 3K and area as 1 by 2. Can you tell me what is the effective capacitance of this scenario? I'll give you 2 minutes to give me the answer. So, everyone got the answer for this one? I can straight away write your C dash as epsilon naught by D into K times A by 2 plus 2. Do we all understand this? How I got this? Yes or no?
Yes, sir.
So the final answer would be, I think, 2 epsilon naught K A by D. Do we understand this? Yes or no? No, yes?
Yes, sir.
Everyone got the answer. I am not getting voices.
Sir,
Yes, beta. Yes, bacha.
so
Did
we
you
can
get
use also other formula, no, sir.
which formula? Other formula?
Epsilon naught A by D into K1 plus K2 by 2.
Yes, you can use that formula also. Not a problem. We get this, yes or no?
Yes, sir.
We got the answer, yes or no?
Yes,
Everyone.
sir.
Can we now move on to the next question?
So 1 minute.
తప్పు ఇక్కడ ఏం ఆల్రెడీ ఏ లోపలనే ఏ బయట ఇప్పుడు డైరెక్ట్ ఫామ్ లో
Shall we move on to the next question?
Yes,
Yes,
sir.
sir.
So we have this question. All the areas are A by 3, A by 3. The dielectric constant of the blue one is K, red one is 2K, and green one is 3K. K, 2K, and 3K. I'll give you 2 minutes to give me the answer of this one. So how are we supposed to do this one, anyone? Instead of 2, we have 3 here. So does it make any difference? No, it does not mean any difference. How will I find the effective capacitance C dash? Epsilon naught by D will be outside. What will be coming inside? K into A by 3. Do we understand this? Plus 2K into A by 3 plus 3K into A by 3. Do we understand this? Yes or no?
Yes, sir.
So that is the answer. What are we getting from here?
2 epsilon naught Ka by D.
2 epsilon naught Ka by D. This is the answer that we are looking at. Everyone understands this? Yes or no? No, yes. Do
Yes,
we
sir.
understand this? Yes or no? No, yes.
Yes, sir.
Have we noted this down, everyone?
Yes, sir.
Okay. Then we will write two small headings. Sorry, one heading, and that is force between the plates of a capacitor. Force between the plates of a capacitor. Force between the plates of a capacitor. Now, what happens is one of the plate of the capacitor is positively charged. Yes or no? One of the plate of the capacitor is negatively charged. So, if the plate that is positively charged has charge plus Q and the plate that is negatively charged has charge minus Q, will they attract each other or will they repel each other? Will the plates of the capacitor attract each other or repel each other? Yes,
Attract, sir.
they will attract. So this plate will experience force in this direction. The other plate will be attracting it. This plate will experience force in this direction. Will the force be equal in magnitude or not? Will the force be equal in magnitude or not? The force will be equal in magnitude but opposite in direction. Do we understand this? Yes or no? No, yes. The force will be equal in magnitude but opposite in direction, and this force is given by Q square by 2 epsilon naught into a very important formula that you must remember. This is the force between the plates of a parallel plate capacitor Q square by 2a epsilon naught, where Q is the charge on the plates of the capacitor. You can also write this formula in terms of sigma, which is the surface charge density, sigma square A by 2 epsilon naught. Do you know what is this sigma? This sigma is charge per unit area. The sigma is charge per unit area. So you can remember this formula in two types. Either you can remember it by the formula of charge, or you can remember it by the formula of force. Do we understand this? Well then, this takes us to the end of this chapter. We are done with capacitance once and for all. I hope you will remember these things. You will note down this formula. I hope you have understood this, yes or no?
Yes, sir.
Yes, sir.
Okay then. We'll meet in the next class. Take care and God bless you all. Everyone has noted this down?